Welcome. Today we're looking at ES6 generators. At its core, generators is a way to loop lazily through data. A generator can do some work and then pause until the consumer of that generator asks for the next value. Let's dive in. We use the same setup than in the previous episodes, but this time I've introduced a file containing 1,000 random words. Before we get all fancy, we just code up a line that reads the contents of the words file into an array. We use the power of ES6 iterators with a for var of syntax to loop through the words and log it to the console. We'll talk a bit more about iterators in upcoming episodes. To do something a bit more expensive on the words in the array, I decided to use the Levenstein distance function to compare each word in the array to all the other words in the array. This function calculates how many characters need to be changed, introduced or removed to make one word equal the other. Think of it as a fuzzy way to match strings. Levenstein distance is quite expensive to calculate, so it will do nicely to illustrate the power of lazily calculating collection-based data. First, I'll just show you how it works. Now we do a distance calculation on tag tree and marquee. We log the distance to the console. Okay, so you have to change 4 characters to make the word tag tree match the word marquee. Let's employ Levenstein on the words array by calling the map function. Map is what we use to transform each item in the array to give us a new array. So in here, we code up an object which keeps track of the closest match to the current item being mapped. Now we loop through each item in the array again and calculate the Levenstein distance between the word being mapped and the other words in the array. We just want to make sure that we don't compare the word with itself, because it will obviously be the closest match every time then. So we skip over it if it's the same word. We calculate the distance using Levenstein. We check whether the distance is smaller, meaning it's a closer match than the previous match. We also have to check whether it's the first comparison. If any of this is true, we store the current word in the loop as the closest match to the word being mapped. After mapping the whole array, we loop through it using the array's iterator and log the results to the console. Now when we run this, you can clearly see that it maps for a few seconds before there it starts looping through the results and logging into the console. So this way does the calculation for each word in the array before we can use that result and log it to the console. Now before we go on to generators, let's see how we could solve this today. Imagine we had a function called wordMatcher. We then enter a loop and ask to get the next item from the object. This result tells us when there is no more data left and we can exit the loop. If it's not done, we expect it to have a value and log this to the console. This pattern allows us to consume the calculation as it happens, instead of waiting for it to complete for each item in the array. Let's code up a function that will satisfy this code. We start by creating the function. We also move the code that reads from the file and creates the word array into this function. We need to keep track of where we are in the array. Let's store an index of -1 here for now. This value will make more sense soon. we return the object the code will interact with and provide a next function on it. The next function immediately increments the index. That's why we specified -1 as the starting value. In case there is no more data left, we return immediately with an indication that it's done. If there is data left, we pull out the word at that index. Now, we can get a code that compares a word with each word in the array. Before we return this calculation, we specify that we managed to return some data and that it wasn't done. When we run this, you can see that we don't have the same delay we had in the previous code. It's spitting out to the console as soon as we start running it, which is quite nice with long operations. Think of it as stateful processing of data. Let's change this code to use generators. The problem with the existing approach is that it's tricky to implement with all the state management. And consumers of this function also need to investigate how it works before they can use it. Generators solve this by bringing this pattern into the language as a first-class citizen. To denote a function as a generator function, you add a little asterisk next to the function keyword. First thing we do is loop through the words array using the array's iterator. Now we copy the guts of our logic into this iterator, and instead of using the return keyword here, we use the yield keyword. Yield does two things for us. It returns data, but it also pauses the loop until the consumer code asks for the next value. In the consumer code, we just need to change it to use the value attribute of the result of the next call. This code is much simpler, and it's baked into the language. And that's it for this episode. We're going to touch on more advanced uses of generators in later episodes, but I hope this gave you a nice introduction to the concept.